let's talk about Parseval's theorem, which allows us to find the power of a periodic signal in the Fourier series domain, or from the Fourier series coefficients. So if you recall, the power of a periodic signal is, this is the average power. It's 1 over the period times the integral, again, over any period of the function squared. Okay. Parseval's theorem states that p of x is also equal to, using the trigonometric Fourier series components, c0 squared plus the sum, it's actually 1/2 the sum from n equal 1 to infinity of the cn squared, or using the exponential Fourier series representation, it's the sum from minus infinity to infinity of the dn squared components. We can write this as breaking the summation apart and using the conjugate symmetry. It's d0 squared plus 2 times the sum from n equal 1 to infinity of the dn squared component. Parseval's theorem allows us to find the portion of the signal power that resides within a frequency band. Actually, the component, the power of the component at omega 0, for example, would be the sum of the d1 squared component plus the d minus 1 squared component, the magnitude, or it's just 2 times the d1 component. Similarly, the power in the component at 2 omega 0 is 2 times d2 squared, and so on and so forth. So these relationships become important when we're interested in determining how much power is within a certain range of frequencies. We can just add up the corresponding power components of that are within that frequency range. That's not a question you can answer in the time domain. This time domain integral allows us to compute the total power in the signal, but it doesn't allow us to compute the power within a band. In order to get the total power in the frequency domain, we have to add up, do this infinite sum of all of these frequency components. So often, if you're interested in the total power, you're going to have to approximate that in the frequency domain, or do that calculation in the time domain. But if you're interested in the power within a certain frequency band, that's where Parseval's theorem is useful. And we can use either of these two expressions to calculate that corresponding portion of the power that's within a frequency band.